Hello and welcome to the show. I'm Martin Willis, your host. And a couple of announcements. First of all, Alejandro is not on the show, and this time it was my choice, actually, and nothing against him at all. Of course, he and I are good friends. It's just that I have a wonderful guest in hour one. I want to make sure I had him for the whole hour. Jeff Bennett is coming up in a minute, and very excited to have him on. He was on the show, I think, a number of years ago. And he was on my other show that I did for a short while. I think we were talking about other subjects other than UFOs and things like that. Tonight we will touch on other subjects as well as the UFO topic as well. In my second hour, I have Prasad on, and he is going to be talking about all kinds of things, including extraterrestrial artifacts, if that's such a thing, and quantum computing and all kinds of very interesting things. So hang in there for hour two as well. Blogs. Last week I forgot to announce our blog, and that was titled UFOs Over Massachusetts. Check that out over at podcastufo.com. And this week is Not So Ancient UFOs. And I learned something by reading that blog myself, only about, 15, 20 minutes away from where I live. In a town called Camden, Maine, there was a 1808 UFO sighting in a diary. It's really quite interesting and really detailed. A school teacher wrote that up all the way back in 1808. And so basically that blog covers through the centuries, mostly from the 18th century when he's saying not so ancient UFOs. 18th century forward, and little tidbits here and there of different sightings. It's very interesting, so check that out. I want to thank everyone that helps out with this show. Race over at KGRA Radio. We also have Keith over at the Dark Matter Digital Network. I've been running over there for a long time. And we have people that help out behind the scenes from graphics to you name it, to the Facebook page. We have a lot of UFO news, so check that out. There's something new up there every single day, whether it's space-related or UFO-related. And so my first guest, I'm going to bring him on right now, is Jeff Bennett. Welcome to the show, Jeff.
Thank you very much.
Jeff, you're an astrophysicist, and to me that's brain-numbing.
Just call it astronomer instead.
Okay.
And astrophysicist is only what we say when we want to impress people.
I see. Okay, and so we're going to be talking about different topics this evening. And one of the things I remember when you were on the last time, and I think it was something like maybe 5 years ago or something like that, and we talked about the Big Bang Theory, and I was trying to argue against it, and you had, I think you said there were 3 lines of evidence, and relativity is based on it. But I have a question for you as far as relativity goes. If the universe was actually contracting instead of expanding, would relativity still hold?
Well, so first I would turn that around. The idea of the Big Bang and how we understand it is we understand it through relativity, but relativity is not dependent on the Big Bang theory at all. Relativity is completely independent and was discovered long before the idea of the Big Bang came out. Now, what Einstein did discover with relativity, which he at first didn't himself recognize and took him later to realize it was actually proven by some other folks that the theory of relativity is not compatible with a static universe. So
the greatest blunder, right? Didn't he say that? It was his greatest blunder?
Yes.
Yeah.
Yes. And so he should have recognized it himself. So relativity actually predicts that the universe has to be either expanding or contracting. So either one of those possibilities would be okay within relativity, but just standing still is not because of the way gravity works. And so when Hubble discovered the expansion of the universe, Einstein called it his greatest blunder not to have recognized that his theory had actually essentially predicted that before Hubble discovered it.
I see. Now, this is probably an odd question, you probably have never been asked this question before, but is it possible that there's a polar opposite of the Big Bang? In other words, where the universe can expand so far and all of a sudden something like we don't really know what happened to make the Big Bang happen. Could the opposite happen and then the universe start contracting instead?
Well, that's actually a very common question.
Oh,
And
okay.
so we know the universe is expanding, and basically your question is, could it be that someday the expansion will stop and it will turn around and end? And we even have a name for it called the Big Crunch,
Oh,
when it all comes
oh,
crashing
wow.
back
Oh,
together. And the answer is we don't know. I mean, certainly that is one possibility. The evidence to date is pointing to continued expansion forever, particularly in light of the discovery that the expansion is actually accelerating, which makes it even seem more like nothing could ever turn it around.
hmm.
But I like to point out that when we say it will continue forever, that also means we have forever to discover something new that might change our minds about that.
Wow. Yeah. And so if it, I think of like black holes and like the more and more black holes there are, like to say if it was contracting, um, I mean, is it possible that all of a sudden the black holes out there could gather more and more material? And, is that part of the big crunch, in other words?
Um,
Thoughts of it?
it would occur as part of the big crunch process. It's not causing it in of itself. You have to remember black holes are just a source of gravity. And the only difference between them and any other source is that when you get really, really close to them, really strange stuff is happening to space and time. But from a distance, there's no difference between, say, a 1 million mass black hole and a 1 million stars. Their gravity would be the same at a distance. And so if there is a big crunch, if the universe starts contracting, then at some point, as it gets very small, the black holes would find it easier to consume nearby matter and grow, and then ultimately they would all merge together. And you may be aware that the idea of two black holes merging is something we've already discovered through
Yeah.
gravitational waves.
Yeah. Yeah. Not all that long ago. Now, when I've heard people say that, or people say it, or I've seen a documentary on this, that I think if you took all the space out of every atom in your body, you would be down to like on a pinhead or something ridiculous, really, really tiny. Is that what happens when in a black hole, the matter just gets condensed in a atomic structure?
Well, actually, it's beyond that. So when gravity takes over, so and this can happen, for example, at the end of a star's life. So when a star has no more fuel for generating energy, that energy in its core is generating heat and pressure, and that's what's keeping gravity at bay, preventing gravity from collapsing the star down. Once that's gone at the end of the star's life, then that core will collapse. And depending on its mass, the question is who wins between gravity and the collapsing core. So for stars like the sun, gravity ultimately fails once the core collapses to a size where the electrons are as closely compressed as they can be without themselves disintegrating. And that's what we call a white dwarf. And so there you have an object that was the mass, the size of the sun, collapsed down to an object the size of an Earth. So that's 1,000 times smaller in diameter. If a star has even more mass than that, the electrons can no longer exist as independent entities. It's a little complex to explain, but it has to do with the strength of the electromagnetic force. And so they combine with protons and become neutrons, form neutrons. So at that point, the entire object collapses down until it's just a ball of neutrons. So that's kind of what you were asking about, sort of subatomic particles. It's all neutrons. And there you've got something that was larger in mass than the sun, compressed down to something that's only a few miles across.
Now,
It turns out that
go ahead.
with even more mass, even the neutrons can't fend off gravity. And at that point, there is no form of matter that exists. It just keeps compressing itself down out of existence to what we call a singularity, and that's when you've made a black hole around it.
Wow. Now, would say there's a star that collapsed down to, it was big enough to collapse down to a black hole. Would the gravity effect of that be no different than it was in its original form? In other words, if
Yes,
you were...
at a distance, it would be. And in fact, we know lots of such black holes. These are black holes in binary star systems. And so you see another star. In a normal binary star system, you see two stars orbiting each other. Here you see one star orbiting something else, and you see lots of material from that star being pulled into that hidden something else, giving off lots of X-rays because it's heated up very hot as gravity brings it in and creates friction as it orbits down to that unseen something else. And from the mass of that unseen something else, you know it's a black hole because there's nothing else that could be that small and that massive.
Wow. And so we know that we have a black hole in the center of our galaxy. And do you
Correct.
think all galaxies, is that what makes a galaxy happen? Basically a cluster?
Oh, that's a really good question. So first, I should say there's basically two different classes of black holes. One is the type that form when a star dies. So their masses are going to be just a few times that of the sun. And we see those all over the place, in these binary systems, like I was mentioning, giving off lots of X-rays. That's how you find them. The other are black holes that are millions to billions of times the mass of the sun. And those are found in the centers of galaxies. So the one in the center of the Milky Way has 4 million times the mass of the sun, which is actually pretty lightweight compared to many others.
Wow.
There is pretty strong evidence that most, if not all, galaxies have a black hole at their center. But one of the big questions is the chicken or egg question, which is which came first? Did the black hole form first and lead to the galaxy collecting around it with its gravity, or is it the other way around? The galaxy forms first and matter down in the center collapses to make the black hole. And no one knows the answer to that question.
Wow. How safe are we as far as like a supernova actually getting us someday? I've listened to Astronomy Cast, and Fraser over there says something like the universe is out to kill us in so many different ways. It's possible, right? But is it in our galaxy that we have to worry about? No further than that, right?
It would have to be quite close within our galaxy to pose any real danger. So we know the kinds of stars that supernova. They're very big, bright stars. So if there were any near us, we would know about them. And the closest star that is likely to go supernova anytime in the next few thousand years is Betelgeuse.
Oh, yeah.
In the shoulder of Orion. And it turns out, for complex reasons, it's really difficult to determine the exact distance of Betelgeuse, but it's probably about 600 light years away. Now, at that distance, the radiation and the particles from the supernova explosion could potentially have some impact on Earth, causing mutations in living organisms and so on. But I would not expect it to be a major influence. It wouldn't be much different than, for example, the effects of when we had the ozone hole forming back a few decades ago. Now, if there were a supernova to happen much closer, that could have more significant biological effects. There are no stars close enough to do that right now, but if you go millions and millions of years in the future, because we're all orbiting in the Milky Way, stars are moving relative to one another, there will be times in the future when there are stars that go supernova nearby, and there have been times in the distant past when that's happened. And there are some scientists who wonder if, some of the big events we see in evolution, when you get increases in the mutation rate, mass extinctions and things like that, whether there could have been some ties to a supernova happening nearby. It's an unanswered question. My own guess is probably not. I think, as I usually tell people when they're worrying about cosmic catastrophes like this, we can't rule them completely out, but we have much more to worry about in terms of what we do to ourselves than what the cosmos does to us.
Right. I think we're sort of undergoing a mass extinction right now. We'll talk a little bit about that when we're going to talk about something that you've been really working hard on later on in the show. But before that, I want to talk about, last time I had you on, you were talking about a project that you did where I think it was somewhere in Maryland or maybe even Washington, D.C., where you set up a replication of what the solar system would be like with the sun the size of a grapefruit. And I remember Earth was a size smaller than a ballpoint pen, the point on a ballpoint pen.
Yes, very good memory.
And the nearest star, the nearest star is in California, right?
On that scale,
On
yes.
that scale.
Yes.
So that's a really good way to explain to anyone out there how far the nearest star is. And,
right.
As far as that goes, what is that, about 4 light years?
Yes. So I'm really glad you brought this up because it's something that we're actually, after not working on it much for a while, we're working very hard on right now. So yes, one of the big things of my career has been working on building these scale models of the solar system. So we build at 1 to 10 billion scale. And on that scale, the sun is about that big. Earth is smaller than the ballpoint in a pen. The moon is that far, 2.5 inches from Earth. And the nearest star is the distance across the United States on the same scale. But on that scale, you can walk the solar system in a few minutes. So we have the Voyage scale model solar system. The one you're mentioning it's on the National Mall in Washington, D.C., right outside the National Air and Space Museum. Mm-hmm. We have a couple others in other cities, and they were all actually based on the one we built first at the University of Colorado in Boulder. And beforehand, you were telling me that you actually lived around here, but we didn't have the model installed at that time. But our Boulder model is now 32 years old, and we're getting ready to replace it with one of these Voyage models. And then we're hoping to replicate them all across the country because they are such a great learning tool for so many things to get a sense of what the Earth really looks like in space. And so anyone can go to voyagesolarsystem.org and learn about how you can get your own Voyage solar system in your community.
Let me ask you, how is that thing displayed? Because when you're picturing like something smaller than a ballpoint and a ballpoint pen, how would you actually even position something like that?
Yeah, so they're attached to these structures that have, some information and color pictures and information about each planet as you go along. And then the planets themselves are in laser crystals. Some of your viewers can see me right here.
Oh, yes. Yep. On YouTube.
Yeah, on YouTube. So I'm holding here a laser crystal that has all of the planets in it to scale, and the sun is the big outline here. You probably can't see it too well.
You can see it fairly well, yeah.
But when you go right up to it, you can see the planets really clearly. So each planet has its own laser crystal on its own pedestal at the correct distance from the model sun in this exhibit.
Yeah, great. Thank you for that. So I want to talk a little bit about the possibility of life out there. And first of all, just thinking about this in general, the first spark of life is such a mystery. And how, I know you, as a scientist, you probably don't like to speculate too much, but I mean, do people theorize in the science world that it was just a happenstance that the first life happened, everything just was exactly right at the right time, and to make the first spark of life?
Well, that's a really big question in terms of, that's why studying the possible origin of life is such a big part of the search for life beyond Earth, because that's a key question. And the question is basically, you can take it down to the fact that at this point, thanks to the discoveries of the Kepler mission and lots of telescopes around the world, we now know that planets are very common in the universe. Almost all stars have planets. We also know that planets the size of Earth in Earth-like orbits are very common. And so now we essentially know for sure that planets of the right size at the right distance from the Earth are all over the place. So the question is then, would they, as happened on Earth, also get life? How likely is that? And to answer that question, you need to look into how you would expect chemistry to work and whether it would naturally point in the direction of life or whether it takes some really odd, lucky event to make life happen. And I would say the general belief of the vast majority of the scientists who study this, including myself, is that the chemistry favors life. I think most of us would say if you have one of these planets, right size, right distance from the sun, and we know there's lots of them out there, that they are most likely going to have life on them.
I mentioned, I think it was 2 shows ago, maybe the last show, caller called in, was talking about life out there. And I said that life is really fights to be here on this planet. You know, when you think of where they have found life, actually since the last time we spoke, I believe, you know, in acidic places and, you know, then deep below the Arctic, you know, where a photon or two of light may come down that way at some point. But I mean, it's just amazing where life will just fight to be here. And, you know.
Yes, and I think that's another thing that makes most of us think that life is almost, you know, we can't, until we discover it, we can't say for sure, but I think most of us expect that life is very common in the universe because it's favored.
Yeah. You know, I know I've always, you know, I've wondered things like, I wonder what the equivalent of someone's first car out there or someone's first kiss out there may be to another being. You know, it is pretty nice to speculate all that. We're going to go into break, and we'll be picking this up when we come back. My guest is Jeff Bennett, and we'll be right back right after these messages.
We're clear, Martin. 3 minutes, just over 3 minutes in this break.
3 minutes. Okay, thank you. All right, Jeff. So we're still on. We'll bring up another topic while we're here and break for this 3 minutes. And so I'm just going to ask you about UFOs in Colorado. Do you know anything about UFO sightings in Colorado, or have you ever looked into that topic at all?
You know, honestly, I have not. We were recently, this summer, we took a hiking trip down to the sand dunes, and I saw there's some sort of a UFO place down there.
Wow. Uh-huh.
But
yes,
no,
the
I
tower.
didn't stop.
Are you talking about the tower?
Yeah.
Yeah. Because I know there's the, I'm trying to remember exactly, Chris O'Brien does a lot of work on it. This I can't, Lewis Valley?
San Luis Obispo.
Thank you, Race. Yeah, I mean, that's a real hotspot, you know, as far as UFOs go. And I know, you know, UFOs isn't really your thing, but you're not closed-minded to the topic.
No, I had a great discussion recently with James Fox, who you probably know. He turns out to be the brother of a good friend of ours, and
how about that? Yeah.
Yeah, we had a lot of fun chatting and stuff. Yep.
Yeah. His, by the way, since you mentioned him, his film was just purchased by 1021. I think that's the name of it. It's going to be released next June or July. So
excellent.
So that'll be great. That's
It's 1091, Martin.
Oh, what did I say?
1021.
1091. Okay, 1091.
Yeah, it's formerly of Orchard. Yeah.
Race, why don't you just stay right here and help me through this?
I'm trying. I don't.
Yeah. Thanks for that. So anyway, that will be coming out next year. Yeah, James is a lot of fun. He's a really interesting guy, and we shared a cab out in Phoenix a few months ago and had a lot of fun conversations. He's great,
Yep.
I don't think anyone works as hard as him either. Not too many people putting together a film like he does. He does a really great job.
Yep.
And so I know that, for instance, in the whole Midwest, there are a lot of UFO sightings, and but I don't think
Martin,
there's.
we're ready to go back.
Oh, you ready now?
Yes,
Okay,
we're ready.
I'm ready here too.
Okay, good,
All right.
because we're ahead of schedule. We're good.
All right, let's
Okay,
go.
here we go. In 5, 4, 3, 2.
All right, everyone, welcome back. This is Martin Willis, and my guest is Jeff Bennett. And we were talking before the break. We were talking about basically the solar system and the distance and between stars and the likeliness of life happening out there. And so I think that is really interesting, the fact that, life most likely is happening out there, and intelligent life. I think it was you're saying that when it comes to intelligent life out there, that can you tell me how that went? That if a society can get through the bottleneck of technology, how did that go exactly?
Well, so that there's two parts to this. The first is, while I think it's very commonly thought that life would be common among scientists, the question of whether that life eventually becomes intelligent is more difficult, because on Earth it took 4.5 billion years before intelligence finally evolved. So that might mean there's a lot less intelligent life than just life plain. But if you do get an intelligent civilization, then the question is, we're always going to get to the bottleneck that we're at today, because the technology that we could use to communicate or to travel into space is the same technology that we can use to destroy ourselves. So the question is, do intelligent civilizations make it past this bottleneck? It's a question we all want to know the answer to, because we're in the bottleneck now, right? And my argument is that if we do get past this point, if we can survive the next century and deal with problems like nuclear war and global warming and so on, then at that point, there's nothing that would stop us from eventually moving out, exploring space, traveling to the stars.
Yes, and the bottlenecks. You mentioned global warming. I know that's some of your study. Before we get into that, though, as far as the technology, we just talked about a star being as far from the East Coast to California when the sun is the size of a grapefruit, the distances. And as far as the technology that we have not discovered yet that would actually make us able to travel that type of space, okay, I have a point here. I'm just trying to think where I'm going with this. Do you think that artificial intelligence is something that's going to be building, something that will make this happen? In other words, that artificial intelligence someday may get to the point where it can replicate itself, and then there's the quantum computing that I'll be talking to the next guest about. And do you think that it's possible that that is what's going to put us there instead of the human mind?
Well, certainly that's an interesting possibility. And in fact, going way back before people really even talked too much about this, the famous mathematician John von Neumann, back in like the 1920s or 30s, or I think, had proposed that it wouldn't be people colonizing the stars, it would be machines, self-replicating machines.
Wow.
And
1920s, did you say?
I don't remember exactly when,
Yeah.
but it goes way back that
Wow.
he was talking about this idea. And you'll find a lot of stuff written about von Neumann machines and whether they might be the things that we should be looking for colonizing the galaxy. And it's just basically the idea that these voyages, even with technology far beyond our own, you're still talking about distances that, because you're limited to slower than the speed of light travel, as far as we know, they're very, very long voyages, and people might not enjoy them that much, but machines could handle them fine, and they could get someplace and then start building copies of themselves and then move on to the next place and so on.
I think that we talked before the show. I told you that I had Seth Shostak on, and I think that that is the only type of situation that he may think is a possibility, that machines might be or could be traveling, but not beings. I think he mentioned something along those lines, and I understand that. But also, it is possible that there's something about the physics that we don't understand. You mentioned that, as far as we know, we're limited by light speed, but maybe we're not. There's
right, warp drive.
yeah. There are possibilities. It's really interesting to, contemplate that whole thing.
Right.
And okay.
Right. Another thing that's worth thinking about here when you bring up the artificial intelligence is also these sort of virtual reality type of thing. For example, you could imagine, in fact, if you saw, there was a Steven Spielberg movie about a video game, Ready Player One, where they had the whole suits and can go into a virtual world where they not only saw like we do with the masks today, but felt and so on. And so you can imagine that we send machines out to other stars and other planets, and you don't even have to go, but you can feel like you're there. So that might be something that people would find more attractive than getting in the spaceship themselves and traveling as well. So it's hard to say where the technology will take us.
Yeah, I know I would. I'd rather do that. So do you think you think we're kind of in a bottleneck right now as far as technology goes? Do you want to talk about that?
Well, yeah, I think by that bottleneck, I mean basically that we've reached the point where we have the technology to destroy our civilization, run us back into the dark ages. And there's multiple ways that we could do that. Perhaps the simplest to understand and most obvious is blowing up lots of nuclear bombs, right? That would send us back into the dark ages for sure. Just general hatred, intolerance, civil wars around the world, that could do it too. But as you mentioned, my big focus has been on global warming because I think that's the one that's most likely to create that problem for us, primarily because it's one that's easy to ignore because it's been creeping up on us, and you have people who try to pretend it's not real and so on, and that makes it one that we're having. Nuclear weapons, it's easy for everybody to say, oh yeah, that would be bad. And we still have them. But hopefully we're smart enough not to use them. Whereas with global warming, it's harder for people to see and therefore more likely to bite us.
I've had this subject of global warming between a few different friends, and I get the comeback of, oh, well, that's a liberal thing, and also there's people are making millions and billions of dollars on it, and that's what it's all about. And so what's your argument? I'm sure people say something like that to you as well.
Oh, those are both very easy to answer. The first is terms of the liberal thing is just look back in time and find out who was the first major global leader to warn about the significant danger of this problem. And it was actually Margaret Thatcher in 1989, giving a speech to the United Nations about this topic. That link is posted on my website. You can watch it at globalwarmingprimer.com. Margaret Thatcher was not a liberal. And so it clearly was not a liberal issue, and that's just a myth that's been manufactured. And the same for the people making lots of money. There are researchers who get grant money, but I tell you, none of them are getting rich. Research salaries are very low compared to what lots of people are earning in the private sector. No one's getting rich off this topic. In my case, I've never received a cent for it. And that's true of the vast majority of people who are focused on this and speaking out on it. On the other side, the people who are spreading the misinformation about it oftentimes are coming from places where they're getting paid quite a lot of money by companies that have a vested interest there.
And can you give us an example of that?
The Heartland Institute has been one of the major funders of disinformation on climate change. I actually had the opportunity to debate someone funded by them who they mail out these things to hundreds of thousands of teachers saying how the IPCC is all wrong. And when I investigated it in detail, and I have a whole post on the website Medium that people can look at for this, it turns out that every study they cite, if you actually talk to the scientists who did those studies, they say they've been grossly misinterpreted by these folks, deliberately misinterpreted.
All right. So how I've been worried about climate change for a while. And recently, I think it was last year, there was a number like 12, if we don't get our act together within 12 years or something like that, we're basically screwed. Can you let us know what you have found out? Where are we? What type of situation are we in right now?
Well, we are in an extremely dangerous situation. The 12-year number is not a specific, hit or miss thing. The 12-year number is based on the models. That's a certain level of warming that we could stave off if we act by that point. If we don't, we're going to have more warming than that. In terms of at what point were you facing a really serious crisis to our future, to our kids and grandkids' future, my answer would be we're already there. The warming that we could stave off in 12 years, to me, is already going to lead to very, very serious consequences for our kids and grandkids. So I think the sooner we do something, the better, and the longer the wait, the more severe of consequences we'll have to deal with before we get the opportunity to hopefully turn it around.
And what would turning it around involve? I mean, it seems like people are going to be sacrificing, and that's what people do not want to do.
Correct. I think that's false, actually. And that's one of the things I would like to really emphasize. Are you still hearing me? Because you froze.
Yes.
Okay,
yeah.
Good. What it involves is we have to not be using fossil fuels for our energy anymore, coal, oil, and gas, which means we need to switch to other energy sources, better efficiency, renewables, nuclear power. None of those give off any greenhouse gases. And the fact is, when you look at the subsidies that we give to fossil fuels, which have been estimated by conservative economists from the IMF and the US and so on at $1 trillion per year in the United States, we're actually spending much more money for our fossil fuel energy than we would be if we were using these other sources. So it'd actually be a net benefit to the economy as opposed to a sacrifice if we were to switch over. And one of the best examples of the analysis done by this is by a group I mentioned to you beforehand. I got to meet George Shultz a little over a week ago, who was Ronald Reagan's Secretary of State. And he's formed a whole group of former Republican administration officials who've done this economic analysis. And if you look at the cover of their report, you'll see it says that this changeover not only solves the problem of global warming, but it strengthens the economy, reduces regulation, benefits working class Americans, and so on. That this is actually something that, even if you don't believe it's real, we still benefit from solving it.
But do you think, I know this is way off, and I hope the listener will hang in there, because I know this is way off the topic we usually talk about, but I really think it's important to talk about. And do you think that there has to be like a complete breakdown of the system, for like the oil companies and everyone involved in fossil fuels? They're not going to give up easy. They're not going to go away easy.
Actually, the vast majority of fossil fuel companies already understand this problem and know it needs a solution, and they're actually advocating for solutions because they need the business incentives that will allow them to make the change in their business structure away from those fuels toward other ones. I mean, the same companies that are doing fossil fuels now are in the best position to do renewables, nuclear, and so on. So they want to make that change, most of them, not all of them. And so they're advocating for the same carbon tax that George Shultz's group is advocating for, the Citizens Climate Lobby, because that provides the market incentive to help them make that transition. And I'll just point out, for anybody who's got more questions on this, my whole book and show is posted for free online at globalwarmingprimer.com, and it's in question and answer format. And I'll probably answer any question anyone has on it. And just to tie it back to our UFO discussion, if there are people visiting us in UFOs, they went through a time in their civilization when they would have faced the same type of threat. Maybe not in the exact same form, but fossil fuels probably exist on any planet that gets a civilization, and they're easy to tap into. So they would have presumably had to have solved this problem just as we're faced with solving it now. So it'd be really nice to talk to them and find out how they did it.
Wow. Something I certainly have never thought of. That's really interesting. I'm not an advocate of nuclear power myself, and that is, for the number one thing for me is not just the danger of it, but the waste we put on our future, 5,000 generations of our future to take care of, and I don't think there's any real good answer for the waste when it comes to that.
Well, that's true, but I can tell you, for example, if you want to know where most nuclear waste is being generated right now, it's actually from coal plants. Coal plants are spewing something like 100 times as much uranium into the atmosphere, because there is uranium in coal, than is produced by nuclear power plants. And with a nuclear power plant, you take that waste and you store it in one place where you can, in principle, keep an eye on it. With the coal plants, it's just being spewed out into the atmosphere where it's affecting all of us. So there's actually a greater total radiation danger from our current sources than...
Wow. I got in an argument in Los Alamos at my sister's house and brother-in-law's house many years ago with a scientist out there that was saying the same thing, and I was calling him BS. So I guess
you can look it up.
He had something to it after all.
No, and I'm not necessarily advocating for nuclear. I'm just saying it's a potential solution to this problem that we should consider. But I think no energy source will ever be completely benign. And so you have to look at trade-offs. And in my opinion, that one's a lot safer than the ones we're currently using. Renewables might be even better or might not be, depending on various things like what goes into the mining and so on.
As far as the renewables, what do you think is it Germany? What country is relying mostly on solar and wind? And there's one country that almost switched right over, right?
Well, nobody's been able to make a super fast transition. There's been a lot of people talking about doing it. The real limiting factor at the moment for solar and wind is storage, right? Batteries or some other form of storage for when the wind's not blowing and when it's nighttime or cloudy. And that problem has not been fully solved, which is part of why I think we shouldn't rule out nuclear before we solve that problem. But if we do, then that might be another way to go.
We have about 10 minutes left. I can take a call if someone would like to call in. Would you like to take a call?
Sure.
All right. So I'm going to put that number up on the screen, and that's going over there right now. And that number is 855-472-5483. So we only got about 10 minutes if someone would like to call in and ask a question.
And while we're waiting, I thought I might mention, because you asked me before about what if we do get through this bottleneck? And I think it's worth a moment on that, because it's something that ties in with global warming when I'm talking to kids also about what does their future look like. And you have to remember, I met George Shultz. I said he's 99 years old. Today's kids won't be 99 until well after the year 2100. So ask yourself, if we survive this century, what kind of technology will we have in the year 2100? And you start to realize, well, we should by then have things like nuclear fusion or solar energy from space and other things that would essentially give us free, clean, unlimited energy. So when you talk about wanting to start sending spaceships off around the solar system or eradicating poverty throughout the world, those all should be possible by that time, if we deal with our immediate problems.
Yeah, it is immediate. We have Vince on the line from Ohio. Vince, welcome to the show. You have a question for Jeff Bennett?
Hi, Martin.
Hi.
Yes. I hate that to hear that scientists think that we are limited by our current physics knowledge, and that I was wondering if you guys thought that if we spent all the time and the money, the energy towards looking at the nuts and bolts UFO technology do you think we would have more answers than what we put into trying to find a signal? I know one day I was listening to you and you almost had Seth in a corner and he didn't let you actually do it. And I just wondered if there would be more information about disclosure, if there was more energy put towards it. I'll take my answer off the air. Thank you.
All right, Vince. Thanks for the call.
Thanks.
You want to tackle that, Jeff?
Sure. I think the difficulty with the question for me is that we have to have something to study. Eyewitness reports are not something that you can really study. You would have to have something in your hands to study. And I think if anyone had that and actually could show that they had something real in their hands, I think lots of people would be putting lots of effort into studying it. But so far, to my understanding of scientists who've looked at these claimed artifacts and things carefully, no one takes them seriously yet. So it's not a matter of that we're not putting the effort into studying it. It's that we don't think there's actually something there to study. We would love it if there was.
Right. That's the one thing that has, we have one more call. I'm going to take that in just a second. That's one of the things that has puzzled me about To the Stars Academy. I don't know if you have even looked at that at all.
I haven't,
But
no.
one of the things is they were stating that they wanted to replicate the technology by observing. And, I haven't been getting that one, understanding that one. And just to your point that you just made, we have Jim calling from British Columbia. Welcome to the show, Jim.
Hi, Martin.
Hi there.
I wanted to talk to Jeff Bennett.
Yeah, he's right here.
Hi. Yeah, I'm an engineer, a metallurgist. I did work on nuclear power, and I learned a lot about it. It wasn't my main job. I worked for a consulting firm, and sometimes nuclear was our customer. Now, I've given lectures on the difference between the engineering method and the scientific method, and I find a lot of scientists, even nuclear scientists, so on, do not understand what's wrong with nuclear power. The problem is the risk calculations. Actually, you can't do the risk calculations on nuclear, and this is why nuclear power cannot get insurance. They cannot get insurance from the private sector. So all governments in the world where they have nuclear power, the governments insure the nuclear power, liability insurance, right? And this is because you can't do the risk calculations, and the nuclear industry, the insurance industry likes to do their risk calculations, or else they'd go broke, and they do them properly, but you can't do them on nuclear. You can't do it. Now, just take a look at Fukushima. It's costing more and more all the time. It's not the cost of the Fukushima disaster is going up over time, not down. Same thing with the one in the Ukraine. Same deal. The cost goes up over time. It just...
Well, I know we're very limited on time, so I'll just try to answer your question there.
Me?
Yeah, we're limited on time, Jim, so...
Yeah. So again, I'm not a nuclear expert, and I'm not saying we should do it. I'm saying we shouldn't take it off the table as an option until we really look into it. And I think the key point here, again, is the trade-offs. And we also can't do the risk calculations for really almost any source very well, but you can look at the historical data. And we know, for example, that the fossil fuel industry does cause air and water pollution that we know about, and that's killing, leading to an estimated premature 10 million deaths per year. Whereas in the entire history of the nuclear industry, there have been the deaths from Chernobyl, but none others. And so you trade off 10 million deaths per year going on year after year after year versus the historical record. Nuclear's safety record actually looks a lot better than the safety record of fossil fuels. But again, we do have to look going forward and make do the best we can to look at it, look at the economics of it. And then I would like to see a carbon tax so that we're factoring in the true costs of the fossil fuels, and then let the market figure it out. If somebody figures out how to do nuclear and can prove that it's safe and economical, they'll do it. If they don't, then we'll be getting our energy in other ways from renewables or other things.
A quick comment, Jim, because we only have
Jeff?
2 minutes left.
Okay, Jeff, you are way off. Way off. Sorry.
I don't think so when you can go to my website and you can see my actual data there. And
I know. I have research papers, my friend. I have the research papers. I don't read websites and environmental stuff. I read.
Okay, just make your point, if you would, Jim.
My point?
Yes.
Nuclear costs too much. It's the risk is too high. And now you mentioned, Jeff, you mentioned something about risk calculations. Look at aeronautical engineering. Look at the problem of getting an airplane across the Pacific Ocean and the risk calculations done in that. The risk is down to 10 to the negative 7. 10 to the negative 7. That's the risk.
The risk for nuclear will never be that low. But the question is, what is the risk? What are the consequences? Can you make it so that it's much safer than it is with today's power plants? I believe the answers to those questions are probably yes. I'm not 100% sure.
No, you can't.
Yes.
That's my job. That's exactly my job. I know.
I've talked to lots of people who do this as their jobs and have done nuclear and do research at some of the biggest nuclear facilities in the world, and they would disagree with you. So I would suggest to the listeners that they go take a look at the actual research that's out there and draw their own conclusions.
It's corrupt. The engineering is corrupt.
Well, so you are now in a conspiracy theory mode, accusing the people who...
I've debated nuclear engineers multiple times, my friend, on this. I have the research papers.
All right.
I have the risk calculations.
Okay, Jim.
Okay, goodbye for now.
Thank you. Yep. So we have just 1 minute left, and one of the questions I wanted to ask you, as far as I mentioned to you earlier on, I said something along the line as we are in a mass extinction event right now because of the rate is so high for extinction, and once something's gone, it's gone. Do you think that's also global warming has a part in that as well?
So far, global warming has played a relatively minor role in extinctions, but it could, most of the extinctions have been due to habitat destruction so far, the burning of the rainforests and things like that. But going forward, global warming, one of the great fears with it is that it could lead to much more extinction, because if climates migrate faster than trees can migrate, then you start to lose ecosystems, and then you lose the animals that depend on them also. So that's actually one of the great fears with it, is that it will lead to furthering of this extinction event that's going on.
Wow. All right, Jeff. Well, that's it for this part of the show. Thank you so much. It's been a real pleasure. Always fun to talk to you, Jeff.
Thank you very much. I really appreciate it.
All right. Take care.
You too.
All right, everyone. We're going to be going into a break, and we'll be right back right after these messages. All right. Welcome back. And this is the second hour of the show, and my guest this hour is Deep Prasad. And welcome to the show, Deep.
Thank you.
And we're
Glad to be on.
We're talking to you in Canada, right? Toronto?
Yes, sir. Exactly.
And did I read something that you were considered at one time in the top 20 of people under 20 or something like that in Toronto? Or
yeah, that's right. You got it.
Yeah.
You got that exactly right.
Yeah.
I believe it was 2014. So, yeah, I was 18 years old when I got it.
All right. And you've done a lot of work. Some have said you're a prodigy. But why don't you give your basic background, if you would, to the listener who doesn't know anything about you, basically.
Okay, sure. So I've always been a fanatic of science from, since childhood. And that expressed itself in different ways. In high school, that expressed itself through competitions and science fair. And then in university, I was kind of all over the place, where I switched from electrical engineering to industrial engineering, and moved from hardware to learning about computational math, and kind of just applying that to day-to-day life. And I found that intriguing. And so I really developed a strong AI / blockchain background. So, for example, I took the first official blockchain like university accredited blockchain course in Canada on blockchain, and
What
that
is
was
that?
fascinating.
What? Pardon me. What is that exactly?
So it's a very broad umbrella term at this point, but think about it as, I would say, a transition or an evolution of the internet. So in some extent, you know how the internet kind of digitized our interactions with people and how we store information. Blockchain takes that and apply steroids to it.
Ah, uh-huh.
Yeah, we can go deeper into it. I'd be happy to. Yeah,
Yeah. And
more questions.
you've also gotten into quantum computing, which is
Exactly.
really and I think there's I'm not sure exactly how many supercomputers there are right now. Is How many are? I know they're building them all the time, and are there like three major supercomputers, something like that?
Yeah. There's lots of exactly. There's lots of rankings of different supercomputers, and there's also different metrics. Usually, we're interested in the number of flops, but there's other ways of measuring how good a computer is and how good a supercomputer is. With that said, though, there's probably, I would say, thousands of what we would define as supercomputers. Different groups around the world kind of competing, whether they're big private organizations like the IBMs of the world, or straight up countries, right? Like the US or Canada. Canada has, I believe, SharkNet and some other, like Canadian central supercomputers. So that being said, there's a smaller number of quantum computers. I would say that there's probably easily less than 1,000, maybe a couple hundred, depending on how lenient you are with calling something a quantum computer.
Well, what I meant when I said the three, I I think there's the top three, right? Isn't there like the top three that are competing against each other as far as being the top? And you're talking about the flops or whatever it is. But these things can calculate something like close to a trillion. Uh, can you
I
kind of
believe
go?
a trillion is small. They can probably calculate more operations than that. If you just looked up, the most powerful supercomputers, it's always changing. I believe you can, verify this. I think China currently holds the lead for what it's worth. I'm fairly certain about that. So yeah.
And what type of calculations per second?
So these are basic operations. We're talking like addition, subtraction, division. Um, yeah, which is why I said that there's different kinds of metrics for calculating these operations and how well a computer performs. For example, you have the complexity class, right? So you have different ways of measuring how complex a problem is, how hard it is to come to a solution, and how hard it is to check the solution. So that's another way of kind of measuring how good a computer can perform. Yeah, a specific task.
And they're not actually using binary, or are they using binary?
Yeah, these are all binary. The ones that I'm talking about, like China and everything, it's all binary. Um, the here's the funny part. The metrics for comparing two quantum computers isn't as well defined. There's not necessarily any obvious way of comparing the different quantum computers with classical computers and with each other. That being said, though, there are some bare minima and some results that we've all agreed on. For example, Google's quantum supremacy results. You might have heard about that in the news.
Mm-hmm.
That's something that there's decent consensus on, was that it is impressive. It is indeed the real deal.
Wow. And so you're someone that's actually considered the UFO topic as well. I've
Right.
seen a couple things out there, and so what are your thoughts on that in general?
Yeah, I believe that they represent the greatest mystery of our time, and I think that it's pertinent that we figure out everything we can about this topic. This is just my opinion, knowing that we'll never figure everything out about it, just like with anything else in science.
Yeah, yeah. Certainly, one of the hang-ups of any science really looking at it is that it's not something that's that you can replicate. It's random. It's not something that can be studied easily in any type of way. There are some people attempting to do that in different ways, but
Yep.
what do you think? Also, I saw that you have an interest in metamaterials. Have you looked into what people are stating out there, what they have found in crashes and things like that?
Yes. Yeah, I've done a great deal of research at this point into different claims by different parties, and yeah, what would you like to know in specific? Is there anything
Have
in
you
specific?
have you actually had a look at any of the materials that people are claiming? That
Yes.
Oh, really? Okay. And so, how would you analyze something like that? What type of
So
equipment does it take?
that's a great question. There's a wide variety of different instruments, and you really have to. What I found helps is knowing what kind of questions you need to ask and what kind of things you're looking for specifically. So let's say that somebody gives you a chunk of metal and it looks engineered, as an example. What do you do with it? The first steps is to figure out, are there anything interesting about the isotopes or the isotopic ratios. So you would go to different labs and you would get a spectroscopy done, and there's a bunch of different instruments, different methods that will give you ideally similar results or similar enough within a varying error, within a acceptable margin of error. So that being said, let's say that some of these results do end up being anomalous and the isotopes are weird. The next thing that you want to do is determine whether you have a meteorite or a actual artifact in your hand, right? Something that might be manufactured potentially off planet, and that makes a world of a difference. But that is like the devil's in the details. Proving that something is engineered off planet is actually insanely hard. So, for example, let's say that I have this alloy, right? I put it under a scanning electron microscope, and I see that, okay, there's this continuous layering. There seems to be obvious manufacturing of this metal, right? People could argue that this is A, natural, or B, somebody took a meteorite and then they engineered they extracted the metals from that meteorite, and then they engineered it into what you're seeing. So it wasn't actually built somewhere off planet. So you see where I'm going with that? So it's very non-trivial, the task. Yeah.
And what would it take? What would you think that it would take for science to actually admit something was actually manufactured extraterrestrial?
We would need something that is obvious technological function, something that, for example, imagine if you had something that resembled a advanced alien microchip. So that's a complete analogy. We would never, right? We would never actually see a microchip like that. It would probably be completely, alien to us. It just wouldn't be obvious. But if we found something that was like that, that would be cool. Or like, imagine an anti-gravity craft or a fully functioning craft. That's game over.
So you're saying that an anti-gravity craft itself. That is that what you just said? Yeah.
Yes, that would be like that would be the greatest scientific discovery of all time.
Right. What about if a metal? I guess what I'm getting at is, what would it take? For instance, there's some metamaterials right now being studied supposedly that people have been talking about in the UFO field, and you mentioned, okay, someone could actually fake something with a meteorite material and something like that, but is there going to be a point where someone would just have to say, this has to be something made elsewhere by another intelligent species? I guess what I'm getting at is, what type of information would they need before it would be accepted by science?
Okay, yeah, that's a fantastic question. let's actually circle back to some of the things that I've done, and some of the things that I've seen. Right. One of the most common results you'll see are the scanning electron microscopes. Now, this will give you only a certain amount of detail, right? It does give you a lot of information, but it doesn't necessarily tell you the function of what you're looking at. So let's say that I took a chunk of my laptop and I gave it to you, and this is in the 1940s. You would still have to figure out, right, what function was this for? And it wouldn't be obvious, I think, that your first guess, I don't think, would be that it was part of a keyboard and it was part of this laptop.
Mm-hmm.
But if you can do that, then now we're talking. So that's what it would take, is if you can identify using advanced scientific principles mixed with, I guess, really good design engineering that people can accept and believe, and you can prove clearly that this is useful tech, you're in the money. So it's not, I guess what I'm trying to say, by the way, is that no metamaterials alone would prove that they're engineered off planet unless they could do something interesting.
You mean they had an interesting function, basically?
Yes, exactly.
Yeah.
Yes.
People have said that there are implants, that people who have been abducted have implants. And there was Roger Lear who was a podiatrist actually, had removed a number of these implants, and supposedly they're being stored somewhere. And I've just wondered if that is the case. Why hasn't there been any study on that? Have you ever looked at that part of the field where people are claiming they're getting implants?
I have, and I've actually specifically, I think, looked at the claim that you're talking about, and I believe that, at least as far as I think patient 17 was concerned, or one of the patients that was actually a scientist themselves. One thing that we need to note is that they used Raman spectroscopy in order to determine if there were carbon nanotubes present inside these quote alien transplants, or like the things that they thought. So the thing about Raman spectroscopy is that you're looking at a graph and you're looking at specific bumps and absorption rates, and based on those absorption rates of the element or the metal that you're interested in, you can infer with some probability whether there are carbon nanotubes inside of it, because they'll absorb a specific frequency, and so that will show up. But that's not other things can do that, and also carbon nanotubes occur naturally in nature. So that was a big selling point, and I don't think it's good enough of a selling point. We can't even prove that there are carbon nanotubes, if you see what I'm saying, because like the spectroscopy alone and the Raman spectroscopy is not good enough. That being said, there were interesting claims about these certain implants that have a radio wave frequency that they emit. So that's pretty interesting. That would be something that's worth probing.
Right. Well, it would be interesting. I know it doesn't. To me, I've thought this part of it, as far as people looking into the metamaterials and all that, is interesting. But I thought it would be extremely difficult to actually pinpoint something down. But you made a really good point. The functionality part of it is something that we wouldn't be able to do. If that was the case, then it would pretty much nail it. But I really don't have hope for what we have so far.
No, neither do I. Don't worry. So frankly, like, that was one of the awakening moments after all my investigation. I think a lot of scientists in background might agree with me, but I'm not going to speak for them. Is that there's a lot of almost all of this is impossible to prove ET life. Frankly, there's not a single sample out there that I could say that, yes, this is it, guys, this is disclosure. Yeah. It's not. It's no matter how close you look at it. And it's not that there's nothing that's weird out there. There is. It's just not good enough.
Right. One of the things I know that you talk about, or you have like this hypothetical scenario, that we may discover that we're quarantined by an intelligent species. Do you want to talk about that? I think that's pretty fascinating.
Yeah, sure. So one thing that I was just toying with is the idea that, okay, based on what Chris Mellon said in that recent article about how UAPs have become more brazen in their incursions, right? They're becoming more shameless in how they interact and more in our face. So what that means to me, I think, is that they have no regard for our rules, no regard for our laws or any of that. So Tom DeLonge is technically right in the sense that we don't have sovereignty. And to me, I think that it's not about politics. It's probably that we are quarantined. We probably are, forced to follow these set of rules. There's this, psychological wall over us, you could say, that we don't see. And so what I was wondering is that, let's say that we do find ourselves in this situation. How do we negotiate with a more intelligent civilization or intelligent beings who have determined that we're too dumb to, have complete sovereignty, or that we just don't deserve it?
Yeah. Well, I could see that case. I mean, as Stanton Friedman would say, we're involved in tribal warfare, and that's
right.
And that's in a way primitive, but I also have talked about on this show that, it is the seeding thing, the whole seeding, situation is pretty an interesting theory as well. If that was the case, if we're just a test, to watch over.
Right.
And would that explain a lot of? Would you think that would explain a lot of what we see as UFO sightings?
In part, yeah. In part.
Yeah.
Some of it, I think, is just carelessness. Like, it could be species that just don't care about our existence. They don't care if they see us. They don't care if we collect evidence. But a lot are probably more careful. That's just my guess.
Okay. I'm going to have to take a break. Unfortunately,
No
I have not talked about this, but I've been really under the weather, and I'm going to have to take a quick break. So I'm just waiting to hear back from Race over there at KGRA Radio, and when we come back, we can talk about basically some other questions along this line. I think this is interesting. One of the things you have said, what do you think is more important, technology or culture? And so hang in, everyone. We'll be right back right after these messages. All right, welcome back. My guest is Deep Prasad, and I do apologize. As I mentioned, I've been under the weather a bit. And so going back to our conversation, what do you think is more important as far as an extraterrestrial intelligent society out there, culture or technology? Now, my last guest, Jeff Bennett, he kind of talks about that, getting through the bottleneck of technology without blowing ourselves up, that type of thing. So what are your thoughts on that?
Yeah, so my thoughts definitely kind of echo those as well. It's that culture in a heartbeat is more important than technology. Technology is something that we can eventually get to, and actually it's a question of if we can even get there, right? Like, we need to be able to survive to a specific point in time, and that's dependent on our culture. And there's other things that are dependent on our culture that we don't see and maybe we haven't discovered yet. So if you think about it, consider this. Eventually, the way that we're headed, the internet is a way of, transferring thought very fast, right? It's something that we couldn't do even 100 years ago. It was impossible. And so people influence each other really quickly, much faster than ever before. And there's much more of us. There's millions and billions of us that are connected to this almost hive mind-like state, right? Where you can't have an opinion other than that isn't formed by everything else you've already seen, right, on the internet or like. So if you extrapolate that, what I see is that eventually our culture will be super, super connected. Even, there's neural link that's coming up, will be connected by the brain. We will become this potentially this hive mind state. Like, I know there's a lot of negative connotations, but realistically, I think that's what will happen. And when or if that happens, that's when culture matters even more, because now you have billions of minds with varying degrees of tolerance for each other's views and emotions, and you can transfer this stuff faster. And so, like, how do you manage that? And that kind of culture has to be super advanced. And at that point, I don't think it becomes culture necessarily. It becomes something more.
So what is this? What do you mean exactly by, you said something like a neuralink, like we're linked to each other, our minds are linked
So
to each
I
other?
was using Neuralink as an Elon Musk example,
Ah,
because like Elon Musk is making the startup, right? So he's making Neuralink, which essentially is a brain to computer interface, and right now it's a bunch of electrodes that you can stick into your brain, and it listens to your brain cells, like your brain signals. And so you could, in theory, once it's a little bit better, you would be able to control your keyboard, or you could control, your mouse just by thinking, because the electrodes are implanted into your brain. And he wants to make it eventually kind of like LASIK eye surgery, like very simple. Like, you get these implants and then you're good to go. I'm saying that we're going to go even farther than that. But yeah, Neuralink is like clearly a step in that direction.
wow. And then there's the singularity, you hear about, which
Exactly.
is just an advancement of all that, right?
Yeah, you got it. So the singularity is more like the hive mind kind of structure that I was talking about, where kind of just join as one,
Hmm.
as this big cyberkinetic being.
Yeah. And do you think eventually it will come down to the point where our brains could be downloaded into something, and we could live on in a machine type of thing, like science fiction out there?
Yeah, I think it's a transient step. It's not our end goal. There's other ways of storing who we are that will be. Think about it this way: matter is very weak. Matter will die out. If this universe dies out, our information dies with it. So a sufficiently advanced civilization, I think, would learn how to store itself across multiple realities. It would have redundant versions of itself. It would be a lot weirder than just being just a digital computer that stores its consciousness.
Wow, interesting. I think I'm going to start taking calls if someone would like to call in. That would actually
Sure.
help me on my end a little bit, just because I'm not, like I say, I'm a little bit under the weather, and I wouldn't mind if someone would pitch in a couple of questions this way. So that number's up on the line. It's 855-472-5483. And what do you think of until the callers call in, what do you think about the future of, quantum computing? Where can that lead? Where do you think that can actually, I mean, can it get out of control? Like, again, like science fiction?
Technically, everything can get out of control. So I guess it's just a question of what will. I'm more afraid personally of nukes, and the fact that people with basically a combination of buttons and voice commands can launch a nuke.
Yeah.
So yeah. With that being said, though, I think that in terms of where the future of quantum computing is headed, I think the future of quantum is photonic. I've mentioned this before as well, like publicly. I do believe that photons is the best way of representing quantum information for the sake of computation, as far as that's concerned. And naturally, I think some of our quantum computing applications that are really interesting involve quantum gravity, trying to simulate quantum gravity in the lab, which is right now not possible.
Can you explain that a little more? I don't quite understand. I don't.
So quantum gravity is a field of theoretical physics that attempts to unify the gravitational and quantum mechanical models of the universe and those interactions. So it looks at how does relativity play a role in the quantum world, and vice versa. This is, of course, you can imagine, so far impossible to do properly. No physicist, no branch of physics has managed it. But quantum gravity does a really good job. Like it's not perfect, but it's getting there.
Okay, I was just looking on to see if we had any questions up on the message board. So the lines are open, 855-472-5483. You're welcome to give our guests a call. So, yeah, the launch codes. That is kind of scary when you think of it. There are several ways of destroying ourselves, and the last guest, mentioned that we are possibly on that road right now with global warming, or
Right.
I'm sorry, climate change. Not
Right.
supposed to call it global warming, but anyway, I don't know. That's it seems like a possibility, but that is something that any culture is going to have to go through. And the last guest made a really good point of it, that fossil fuels are very easy to interact with and to use, and could cause a similar issue that we're having right now. And
Yeah, I agree. And frankly, like when it comes down to it, fossil fuels and any known fuel source we have, they don't really have a good enough energy density compared to what we think is going on when it comes to, let's say, the UAPs that we're observing.
And about what we're observing, if you had to guess where they're coming from, would you think that they're extraterrestrial? Do you think that's a likelihood, or do you have a question about where they're coming from?
I mean, that's the $1 million question, right? I think some of them are extraterrestrial, but basically all of them, or a lot of them, are something that we don't have good enough words for yet. Ultra-terrestrial doesn't count. Interdimensional isn't good enough. I think it's something that our physics and philosophy hasn't quite, encompassed just yet.
And where do you think that will lead in the future?
Yeah, good question. So basically, it comes down to, on the physics side of things, we essentially need to understand how different kinds of life forms may be able to live in higher spatial dimensions, for example, and whether that's possible. Because one thing that we're seeing almost time and time again is that the nature of the encounters that we have happen anywhere. So they can happen in any state of mind that you're in, whether you're dreaming, you're on, let's say, DMT, supposedly, when you're completely wide awake, you can still have what's called an abduction experience, right? Like, let's say, Travis Walton. So all of these are examples of something that is able to exist everywhere, which is weird. And to me, that means that it sounds like something that's spatially higher than us, because that's what I would think if I was in Flatland and somebody put like their hand through my, world, right? I would see 5 different points of the hand, but it's all connected to just one hand. But it would seem like they're all totally, different phenomena, so to speak.
We have a caller. We have Vince. Vince again.
Sure.
Vince once again from
Hey,
Ohio.
Martin.
Hi.
I'm sorry. I'm asking the easy questions, but I wondered, what does your guest think, if he's familiar with the manipulations that we had with our nukes in the past? What does he think failed?
Oh, you mean as far as UFOs and nukes?
Yes.
Have you ever looked into that topic, Adeep?
Yeah, certainly. I think that's an important question, right? Because we're spending billions of dollars in the security of these ICBMs. And here you have these technologies that can hack it. But more importantly, I think the message is very clear. We need to just stop playing with them. It's obvious that they don't want to bother talking to us, and therefore, any kind of interaction with something that might be more intelligent than us is going to be important. So if they're just flying over and shutting down our nukes, let's listen.
Great. Thank you.
Yeah, no problem. Thanks for the question.
Yeah, thanks for the call. Yeah, that's always been such a interesting part of this whole phenomenon. That part of it. I think I mentioned Stan Friedman earlier. He said the kids found the matches. That's what that's what he puts.
Right.
As far as the nukes go, and I had heard about this. Before I really looked into the UFO topic years ago. I had heard about nukes and UFOs over them. Back in the 1990s or something like that. We have another caller. I'm going to take that in just a minute, and so that number is up on the screen: 855-472-5483, and we have Andy calling from Connecticut. Welcome to the show, Andy.
Hi, guys. Thanks for taking my call.
Sure. Thanks for the call.
I wanted to ask Deep. Great. So I wanted to ask Deep real quick if he thinks that Moore's law, where computer speed is constantly increasing, if that will continue to be the case for the foreseeable future, or whether it'll outpace, the traditional standard we've seen over the last few decades, or just his thoughts on where that's all headed. And I'll take your answer off the air. Thanks again, guys. Good show.
Thank you, Andy.
Yeah, thanks. So, essentially, I think Moore's law at this point is telling us that there's almost no more ways to improve the current size of our transistors, and therefore very little ways and dwindling ways of increasing our compute power without spending lots of money and engineering just to increase it a little bit. So if you want to think of a practical example, consider transistors that exist today. So we have transistors that are almost a couple atoms big, and when you get to that scale, quantum effects start dominating. And so you'll have these things like quantum tunneling that the electrons will do that you don't have with bigger systems. But this quantum tunneling is something that you don't want. So Moore's law is kind of at the end of its tail, where we've pushed it to its limits, and now it's time to look at different ways of compute, because Moore's law was specifically for binary classical computers and binary processing techniques.
Are there going to be other types of processing, do you think? Is that basically what you're saying besides binary? I know I mentioned that earlier.
Exactly. There's already quantum, right? Quantum is one example. And even within quantum, there's different kinds of processing. So there's qubits and then there's Q modes. Qubits are superpositions of 0 to 2 to the n states, whereas with Q modes, you have an infinite number of possible states that one Q mode can take on. So you have all these different ways of representing information even within quantum, and I feel eventually we'll go beyond quantum as well, right? We'll have a different model, and that'll have its own compute paradigm.
Yeah, which could almost be scary.
Yeah.
We have Bim calling from California. Welcome to the show, Bim.
Hi.
Hi.
I wanted to ask your guest, do you know of Lee Smolin and his new theory of time?
No.
Wow, that was a quick call.
He's a top theoretical physicist.
Great. So what's his theory about?
He says, well, if you look at general relativity, we live in space-time, right? And he says that time, the dimension of time, is the same as the other dimensions. It's just that we perceive time differently. and his name is Lee Smolin. He's been put in the top 5 theoretical physicists in the world, so I assumed you might have thought of him or might know of him. But he says that we might have to throw out the scientific method because of this, because things don't happen in order. You have to do the scientific method in order, right? But if time is not as we perceive it, then we have to throw out the scientific method. Even that's one of his statements. I don't know what you think about that.
Yeah, I mean, it's fantastic that you bring up that theory. I'm always cautious when someone, no matter who it is, says that we should throw away the scientific method, right? Like, let's take, for example, so I'm not too much into relativity. Like, I'm not a relativist. I would say more of a quantum physicist and quantum computing scientist. So, in quantum experiments and quantum mechanics, we do have experiments where you have, let's say, the quantum eraser experiment, where it's as if causality seems to be broken in the way that we would normally expect it to. So you can have information that somehow can seemingly travel backwards in time. And you could say that this is breaking the scientific method or that it no longer applies. But I think it just means that we need to get more creative.
Okay. That's interesting, yeah. I'm trying to think of some of his other quotes.
Sure.
Anyway, he says that he's trying to replace general relativity as Einstein replaced Newtonian physics. He says that's how big his theory is, his new theory of time. It's that gigantic, And I'm not too much up on quantum theory. I don't know, but it's interesting. But I've done experiments in consciousness,
cool.
And I've actually done it and experienced it. I've taught it to others, and they did it in front of me, so I've seen it. I'm an engineer, so I use that method. I've seen it with my own eyes, right? So and this fits into the whole ufology thing, because and the native people too. Actually, the indigenous people of the world knew about these things. They knew about they knew that consciousness was not local. And they use that to survive. I study anthropology as well, and I have a lot of native friends and so on. I've learned some of their tricks and so on, and it's a different kind of knowledge. It's not scientific knowledge, I guess. Not now. It could be someday. But the USSR did an amazing experiment where they were killing baby rabbits. I wonder if you've ever heard of that.
No.
They found that when they killed the baby rabbits, the mother rabbit responded at the same time. So they took the baby rabbits into another room and they wired up the mother rabbit's brain, and they got a signal when the baby rabbit was killed. So they took the baby rabbits down in a submarine as deep as they could go, and they killed the baby rabbits down there on a secret time schedule. And up on the land where the mother rabbit was, her brain responded at exactly the same time. So they got the responses, right? And so what they were trying to do is to show that this connection between minds, this communication between mind to mind, is not dependent on the electromagnetic spectrum. That's why they took the baby rabbits down in the submarine to eliminate electromagnetic the electromagnetic spectrum. So what they're showing is that there might be some other spectrum.
Mm-hmm.
Is that possible, other than the electromagnetic spectrum? I find humans are so focused on the EM spectrum, right? Because our eyes are our main sense. But wouldn't that be interesting? What is the medium that carries the mind-to-mind connection is the question I ask, because I've done it many times. I can communicate with wild animals and things like that. The native people did this too, eh? They knew all about this stuff. And so I've demonstrated it to myself and to others, and I know other people who can do these things as well. So the question becomes, how does this, what carries the mind-to-mind connection? That's the question I'm looking at.
Yeah, Well, when it comes to, let's say, anything to do with consciousness, one thing that we should always do is make sure we define what we mean by consciousness, right? So, for example, I could cheat and say that my consciousness is everything in the universe, including myself. Like, there's no separation. So then I define consciousness by saying by saying that it's equivalent to defining the universe. And suddenly you're getting nowhere, right? So one thing though that I wanted to say though about that rabbit experiment is that what Albert Einstein would say in this kind of situation is that there's still hidden variables that you need to rule out. So let's say, going back to the rabbit, I'm not saying this is possible, like there's 100% chance. It's just an example. The hidden variable in that experiment would be that the rabbits over time learned English, and eventually they overheard, because rabbits are good at hearing, they overheard the plan of killing her children at a specific time. So at that time, the rabbit, knowing English, having learned it internally, even, you know what I mean, knew that it was time for her child to die. So it might not be connected. I'm not saying that's yeah.
Their science was very good. They used random number generators to generate the times for killing the baby rabbits and put them in an envelope. And, it was very well done, scrupulously done science.
Yeah, incredibly dark, too.
Well, I just want to say one thing. Who could kill baby rabbits for
No, yeah, I was just saying incredibly dark.
Yeah. Anyway,
it's for science.
Yeah, I don't care. All right, Bim, thank you for the call.
Yeah, fascinating discussion.
All right, interesting. So we had a question in the chat room. Let's see. Someone wanted to know where quantum computers pull their data from.
Okay, so I'm not sure what they mean by that per se. Like, for example, you could have like quantum RAM, QRAM, or you could have quantum processors. But if you mean, how do you leverage quantum data? Like, for example, how is it even possible that we can leverage quantum effects? That's possible when you specifically. It depends on the physics of your system, the hardware. So let's take, for example, D-Wave's superconducting qubits. So you have these wires where you cool them down to the point that they are superconducting based on a specific threshold temperature. Usually it's a very, very cold temperature. So we're talking about millikelvins. So like 3 or 4 thousandths of a Kelvin, just above absolute zero. Degrees. So in cases like that, the quantum information, the quantum data, so to speak, that the quantum computer is pulling from, you can say that's coming from the quantum state that you've now created because you're in this superconducting state, and then because you applied these Josephson junctions, and then you pulsed it with magnets to get your specific overall quantum state.
I see. So as far as your interest in UFOs, we have about 5 minutes left here. And as far as your interest in UFOs, what part of the subject are you looking into most? Have you actually done any research of any cases in particular, or is it just a general fascination?
Yeah, both, like general fascination, and I'm looking into the Tic Tac incident, right? So, for example, with the Tic Tac, I'm going out to the Catalina Islands with Kevin Day and Dr. Kevin Knuth and some other guys.
You're part of that. I didn't even know that. Wow.
So,
let's hear about that.
Fact, I'm the vice president of technology for the organization. We're essentially another SETI, right? So we're an evolution of SETI. That's how we're kind of framing ourselves. And my role will be to oversee the technologies, either integrating ones that exist or developing new ones for detecting and tracking these UAPs and creating different technologies, that are related to the UAP topic.
Interesting. Well, I'm glad you're a part of that. That's fascinating. I don't know if you, a number of people have told me to watch this video, and I watched it recently. And basically, it's a guy. I think his last name is Murray, Michael Murray, or something like that, is claiming that he was an Air Force intelligence officer, and that
Yeah, I watched some of it.
you watched some of that, yeah, and that it was basically the Air Force messing with the Navy. And I had sent that to Kevin and wanted to get his reaction. And so what is the general consensus of that? I made a comment, I kind of thought there was a lot of red flags that went up when I was watching that. And I wonder what your thoughts are.
Right.
Yeah.
Yeah, no, I'm in complete agreement. So the parts I listened to, the one thing that stood out to me is how much faith he was putting into using the UFO patents, those patents that so he was saying, oh yeah, so this is how this works, and it was completely superficial knowledge. Like, he clearly didn't understand what he was talking about, and that was a huge red flag to me, because he was using that to confidently debunk the Tic Tac. So I'm like, all right, this guy doesn't know what he's talking about, or he does, and he's purposely just trying to fool like the laziest percentage, of people.
Yeah.
So that was my view. But I just felt a vibe of overall nefariousness for whatever reason.
Yeah. Well, there was some fast talking and some technical talking and all that, but I wasn't. I don't know. There was a lot of things that he said that made me think that it wasn't too well to be taken seriously. And one of the things, whenever he was asked about anything specific, he acted like, oh, it was classified and he can't talk about that, but he could talk about everything else. So as soon as he got nailed down, he anyway, I don't know if the listeners have paid attention to that or not, but anyway, so is that actually
that's next November.
So you're leaving next November, and you're going to be on a boat, right?
Exactly. Yeah, for 10 days.
Wow. Wow, that's exciting. I can't wait for that to happen, and I'm sure I'll probably have Kevin on before that happens. Well, that's it for us tonight. Thank you so much for joining us, and thanks for hanging in through the extra break we had to do. But
yeah, no worries.
Yeah. All right, everyone. So that's going to be it for our show. Thank you so much for watching and listening. And we will be back next week. I can't wait for our guest next week. That is Bryce Zabel. And he's always very interesting. And it should be a great show next week. So I want to thank everyone else. I want to thank everyone that helps out with this show. And again, we'll be back next week. And remember to keep your eyes to the sky.